Okay, starting up where we left off here on the metric scale. So please review over as far as what I talked about with numbers if you are starting this video a little bit later than the first one. So we get to this point where we have to start doing what's called dimensional analysis. We have to do it between basically the metric system and the metric system like together, or the metric system and the English system. Well, the English system is what we use. Feet, yards, things like that. Where the metric system is in meters, centimeters, millimeters, that scale that we just drew. So this is asking us a couple of questions that we're going to do conversions on. And then we're going to do a couple more examples. And then there are even maybe a few more that, depending on time. Okay, so this says how fast is 90 kilometers per hour in meters per second. So guys, this is a unit right here. So we've got a number and we've got a unit. The unit is what makes this physics versus math. So in math class, you just have the 90. In physics class, you have a number with a unit, which actually means something. So that's what I always, joke about with the math teachers, is that the physics is actually meaning something. It's a banter back and forth that we have constantly. So this is wanting us to figure out not in kilometers per hour, but in meters per second now. But it is also going 90 kilometers per hour. But the general rule for physics is that things are typically in meters per second. Okay, so we have to usually do this conversion quite often. So what I tell people to do is write it out kind of like this. So you've got 90 kilometers per 1 hour, essentially. You don't obviously have to write the one, but it kind of helps make sense. And then you have to draw these tracks. Guys, this stuff is some of the hardest stuff for people to grasp at the beginning of this class. So if you get through this and you go, I just don't even know what's happening here, then you need to email or you need to call and we need to Zoom and you need to figure it out, because it is not going away. Okay? I know that this is an online course, but you're still going to need to communicate. All right. So I always work with the top unit first. So we've got kilometers. So whatever's on the top is what you write on the bottom right of it. So then I say always go to the base unit. Well, the base unit is here in the middle, okay? This is things like meters, liters, grams, moles, etc. Bytes. You've heard of gigabytes, megabytes. Okay, that's part of this metric scale here. So the base unit is whatever it is without a prefix. So the prefix in this case being kilometers. So we need to go to the base unit, which is meters. All right, then you got to ask yourself, which one of these things is bigger, a kilometer or a meter? So you got to look back at your scale. Well, kilo equals 1,000 and meter only equals 1. So which one's bigger? A kilometer. So when you go to fill this out, you always put the bigger thing as a 1. So like the kilometer is the bigger thing, so it gets a 1. Well, how many ones does it take to make 1,000? Like how many $1 bills would it take to make $1,000? Well, it takes 1,000. So that's kind of how you fill it out. So now we would cancel these, okay? Because there are ones on top, ones on the bottom, like a fraction, so it would be canceled. So now we have meters per hour as far as units, but we don't want that. We want meters per second. So we have to extend our tracks here. So look, see how hours is on the bottom? How would we cancel that out? Well, we'd have to put it on the top. And we could go directly to seconds, which is what I would suggest to do. Now, you might not know how many seconds are in an hour, but I'll tell you. Which one's bigger, an hour or a second? An hour, so it gets a 1. And there are 3,600 seconds in an hour. You know how I figured that out? 1 hour is 60 minutes, and 1 minute is 60 seconds. So if you take 60 times 60 in your calculator, you would get 3,600. Right, now this is what you do on your calculator. So hopefully everybody's gotten their scientific calculator at this point, because you need one. So you do 90 times 1,000. Well, let me take it back. You can multiply everything on the top and then go and divide everything on the bottom, or you can go in stages like this, and then this, and then this, however you want. If we do the stages, it would be like 90 divided by 1. Well, does that change it? No. So whenever there's a 1, you really don't have to do that on the calculator, but some people like to. So 90 divided by 1, and then you go to the next bracket. Well, if it's on the top, you multiply. If it's on the bottom, you divide. So multiply by 1,000, divide by 1, multiply by 1, divide by 3,600. So you get 25. Your hours canceled, and you'd be left with meters per second. And that would be the answer. Okay? So let's do this next one. It says, how fast is 90 kilometers per hour in miles per hour? Well, guys, this a mile is an English system unit. So that's one of those things where I'd have to give you a conversion factor. So I think for every mile, there's 1.609 kilometers, something like that. And you think, well, how do you know that? Well, I have a bunch of useless information in my head over the years, is all I gotta say. So I was gonna double check really quick, but phone is being weird. All right, so what do we do with the kilometers? Well, if it's on top, then we have to write it on the bottom. So, and we're going to miles. And we have a conversion factor straight to miles here. If it wouldn't have been straight to miles, then we would have been maybe having to do like another conversion, but we don't have that in this case. So for every 1 mile, there's 1.609 kilometers. For every 1 hour, oh, we're already in hours, so we don't need to do that. All right, so we have 90 divided by 1 times 1 divided by 1.609. So we end up with 55.9-ish miles per hour. Or you can write it mph, because that's what it is like on your speedometer in your car, huh? Okay? So sometimes you have to go back to English system units, or from English system units to metric units, which this is a metric unit because it's in meters. Metrics, meters, okay? So I have another blank slide here for a couple of other examples that are in your textbook. You guys should all have a loose leaf book that you would have purchased either from the bookstore, or you could purchase it directly through McGraw-Hill as well. I think it's going to be around the same cost though. So this is example 1.2 in your textbook, which is on page 12. If you want to go through it with me and read it. It says, if you're told that there are 2.54 centimeters in 1 inch, how many centimeters are there in a foot? All right, so it says that there's 2.54 centimeters in 1 inch. And part A wants you to figure out how many centimeters are there in 1 foot. Okay, so this is where we need to do some dimensional analysis again. So you've got 1 foot. You always start with what you've been given. Well, this is what we've been given. draw your tracks, and we're trying to get to centimeters. So if feet is on top, what does it has to be on the bottom right for it to cancel? It has to be foot again, okay? Now, going back to our conversion factor, do we have a foot to a centimeter conversion here? No, we have a inch to centimeter conversion. Well, can we get from feet to inches maybe? So this is a conversion that I would not give you. You would be required to know that there are 12 inches in a foot. Just all there is to it. I had an engineering student once that was like, so we just have to know that? And the answer was, yes, you need to know that there's 12 inches in a foot. Sorry. So since inches is on the top left here, we have to put inches on the bottom right so that it'll cancel. Do we have a conversion from inches to centimeters? We sure do. So for every 1 inch, there's 2.54 centimeters. Now get your calculator, do 1 times 12, you could divide it by 1 if you wanted to, times 2.54, and again, you could divide it by 1 if you wanted to, but you should get about 30.48 centimeters. Okay? Part B says, how many meters does 1 foot represent? Okay, so this is wanting us to figure out meters. So if I were you, I'd start all over again. So we have 1 foot, and we're basically doing the exact same thing as part A, because this is our only conversion factor again, and we don't have a foot to meter conversion. So then we go from inches to centimeters because that's all we got. Well, now what? How could we get from that to meters? We're at centimeters now. Could you go directly from centimeters to meters? And the answer is yes. You have to go back to your metric scale here. And I like this one because we haven't talked about one that deals with something on the right side of the scale. So look at your numbers here. You've got meter, which is 1, and you've got centimeter, which is 0.01. So which one's bigger? The meter. Okay, remember what we do with the bigger one. We put a 1. Well, how do you know what to put for the centimeter? A lot of times people will mess up and they will put 0.01 for that number right there. But that is not what you do. You would take that 0.01 number and you would flip it. So if you flip it and pretend that decimal is not there, then you end up with 100. So it takes 100 centimeters to make 1 meter. So if you ever were to see a meter stick, it looks about like a yardstick. There would be little dashes on there that represent centimeters, and there's 100 of them because it takes 100 centimeters to make 1 meter. Okay, so on your calculator, do 1 times 12 again, times 2.54, divided by 100. Okay, that's going to give you 0.3048 meters. That's what you're left with. Okay, so that's how you do example 1.2, both A and B. We're also going to do example 1.3 on here really quick. So we've got, if the rate of flow in an automatic watering system is 2 gallons, and I always tell people, write down what it gives you in the problem, even if you don't want to. 2 gallons per hour. How many millimeters per minute is that? So it wants us to find millimeters per minute. All right, so definitely start with what you've been given, okay? So 2 gallons per 1 hour. Well, going from hours to minutes is pretty easy, but going from gallons to millimeters is a little bit different than that, okay? So you need a conversion factor again. So it's going to give us 1 gallon is equal to 3.786 liters. Oh, I said millimeters on here and I meant milliliters, by the way. Milliliter, not millimeter. That makes more sense. And for whatever reason, it's not letting me get my eraser out, so sorry about that equal sign there. Oops. All right, so we're gonna go from gallons to liters because that's the conversion factor that we're given. Okay, I would never make you memorize that 1 gallon is 3.786 liters. That kind of stuff would be given to you on a quiz or a test, okay? Then we have to go to milliliters, okay, not just liters. So we have liters to milliliters. That's where you have to go back to the scale again. Well, here's liters, here's milliliters. Which one's bigger? Well, the liter is, right? So the bigger one always gets a 1. And how many milliliters are there in a liter? Well, you take that number and flip it and pretend like the decimal's not there. So that would be 1000. So 1,000. Okay, that gets rid of gallons and liters, and that leaves us with milliliters per minute. So we're almost there. Now we just gotta mess with the hours. So since hours is on the bottom, we have to put it up on the top. And we can go directly from hours to minutes easily. So for every 1 hour, there's 60 minutes. Now we just have to do the math here. So you do 2 times 3.786 times 1,000 divided by 60, which is going to give you 126.2 milliliters per minute. Okay, I know that stuff is tricky, guys, and what I think I'll probably do is when I give you some homework problems, I will try to have some that are like counted and then some that are practice, so that you can kind of go through and practice if you want to and see if you get the correct answer. That's all this takes, guys. Physics is just one of those things that takes a lot of practice, and people think that there should be like the exact same problem, you know, on the test as there is on like a homework, but it just doesn't work like that. So you really need to understand why and what you're doing when you're doing these physics problems. You cannot memorize this stuff, okay? So it just gets us into this idea of why do we even study this? Well, it's all kind of connected. It's saying that a bicycle wheel is kind of like an atom. See, here's an atom with proton and electron, and there's just this sort of spinning motion. Well, then they're saying, oh, it's also kind of like a galaxy, you know, and all of it has to do with angular momentum. It's all tied together in the same kind of idea. Just like when we talk about torque or angular momentum, you know, just like it has here, all of that's involved in your body, okay? So this stuff is very applicable to what you will, you'll have for, you know, your next step, especially if you're going into the PTA program. All right, practice problems, like I said, I think I'm gonna have some of those on the homework as just sort of an addition to, so you don't have to do the ones that are considered practice, but you will definitely have to do the ones that are for credit, okay? And again, if you have any questions or problems with things, I strongly suggest that you contact me and we go through it together via Zoom, or you could come in during my office hours, just, you know, like a in-class person could. Whenever you have time, as long as it's the time that I can, then we can definitely make it happen. All right, I'll see you guys.